Hey everyone, welcome to another session of BTM Math, and today we will be discussing volume. Now, volume is the same idea as area but with depth. So if you remember in the previous videos, when we would go over area, we'd be looking at the length times the width. And now, when we look at volume, we have the width, the length, and now depth. So let's look at what that means. The first item that we're going to look at will be a cube and figure out how to get the volume of a cube. So if we have a cube here, 3, 3, and 3. So length, width, depth. We know that the volume of this is length times width times depth. And this equals 3 times 3 times 3. And if we multiply all these together, we end up getting 27. And this will be units cubed because we're going in 3 dimensions. Now, similar to a rectangle, we have a shape called a cuboid, which just as a square has all equal sides, so does a cube. And a cuboid is like a rectangle compared to a square. So let's make the length 3, the width 4, and then the depth we'll make 10. To find the volume of this, it's the same as if we're finding the volume of the cube, so it's going to be length times width times depth. In this instance, we have 3 times 4 times 10. If we do some quick math, and we see that this ends up being 120. And of course, this is units cubed. Next example that we're going to look at is referred to as a triangular prism. So it's similar to a triangle, but with that added third dimension of depth. So if you remember, the area of a triangle was 1/2 of the length times the width. And just as in the previous problem, when we add volume, we add another dimension to it. So now we have 1/2 length times width times depth. So let's see what this looks like in a problem. Let's say you want to figure out how much water is in a swimming pool that has a shallow end that starts at nothing and it goes to a deep end. And let's say for the length here we have 10. For the width, we'll make this 20. And for the depth here, we'll make this 5. So if we want to calculate the volume, take 1/2 times 10 times 20, and times 5. So if we take 1/2 and we're going to multiply it by 1000, and of course this equals 500 units cubed. If we do another example, we'll make this one 4, 8, and 10. So again, volume equals 1/2 times 8 times 10 times 4. So this will give us 1/2 times 320. That gives us 160 units cubed. The next object we'll be looking at for volume is a cylinder. Now you can see that this is similar to the circle, and if you recall, the area of a circle is pi r squared. Now if we take our cylinder and we add another dimension to it, the volume equals pi r squared and multiply by the height. So make this h, and of course this one here is r. So let's see what that looks like in a problem. In this problem, our cylinder has a radius of 4 and a height of 12. If we plug these numbers in, volume equals pi times 4 squared times 12. If we do some math for this, we'll see that this is pi times 16 times 12, and this ends up giving us 192 pi units cubed. You can leave it as 192 pi, or if you feel the need, you can multiply this answer by pi. So then it would be 192 times pi units squared. Let's go over one more. In this problem, our cylinder has a radius of 5 and it has a height of 6. If we take these numbers and plug them into our formula, we get volume equals pi times 5 squared times 6. And if we start working this down, we'll see that we have pi times 25 times 6. This gives us 150 pi units cubed. If you have any further questions, please let me know. There will be additional videos posted going in more depth and more examples of each one of these types of problems.